represents your gradient, right? Now, let us move on to the next question, which is question 9. Here we'll be dealing with a cubic function. Now, the first step, or rather, question 9 says we're given a graph of cubic function, which is f of x is equals to, now we are given the standard equation, so we were not given the equation of the function. We're given ax cubed plus bx squared plus cx plus d squared, meaning that somewhere, somehow, there would be a question that requires us to determine the equation of this graph. Now we're given points on the graph. Now they say P, let me just write down the points which I'm given. P 0 and 6. So this is point P. I'm also given Q, which is at 1 and 0. Now I was not given R, but then I was given point S, which is at 3 and 0. And this is my point at S. All right. Now they say R and S are points on the graph, right? And then Q and R are changing points, which are your stationary points. Now, these two are your stationary points. Now, the first question, show that A, which is this, is equals to negative 2, B is equals to negative 10, C minus 14, and D is 16. Basically here, they're asking us to prove that the equation for this function, it is minus 2x cubed, right, plus 10x squared minus 14x plus 6, right? Now, every time whenever I am asked, or rather I have this kind of question on calculus whereby I'm required to determine the equation of a cubic function, I use, or I make use of this formula whereby I say y, right, my y is equals to a, so it's going to be x. So it's going to be x minus x1, right? Now these are my intercept, right? My x-intercept points. Now the second is going to be at x minus x2, my second x-intercept. Now this, it's all squared. The first bracket squared, right? Now, as I've said, these x1 and x2 are my intercept points. So my point at Q, I'm going to make it x1. My point at S, I'm going to make it x2. Now let me go about doing that. So this is the same as y. So y is equals to, right, x minus 1. Now remember, this is squared, and as well as x minus 3. And there is a here. I've omitted to place in the a. So now, as I've said before, x1 as well as my x2 are my x-intercept points. All right. Now, after, I need to substitute any point besides point Q and S, which is present on my graph. Basically, after you've substituted your intercepts points, which is x1 and x2, you need to substitute any point on the graph which is not your x-intercept. And in this case, it is point P, right? We need to substitute this point. So I know that at P, my y is equals to 6. So I'm going to say 6 here. And this is equals to, basically here we will be solving for A. A. Now, what is my x value at P? It is 0. So here it's going to be 0 minus 1 squared. Same applies here. What is my x value at P? Is 0. So it's going to be 0 minus 3. All right. And from there on, you can punch this into your calculator. You can just say bracket 0 minus 1 squared multiplied by 0 minus 3, right? And if you punch that into your calculator, you would get, now punching that into your calculator, right? So basically, this is going to be 6. It's equals to minus 3a. From here, remember, we are solving for a, right? Hence, we're going to divide both sides by minus 3. Dividing both sides by minus 3, so that our value of a can be equals to minus 2. All right. Now, we have solved for A, we need to solve for B, C, as well as D, or rather prove that these actual values, right, are the ones in which we are going to calculate. Now, let us continue with this. After you have calculated your value of A, right, so the first step is that we need to calculate the value of A. Now, after we've determined our value of A, we need to go back to this equation, right? The initial or the original equation we used, whereby it was y is equals to A, x minus x1 squared multiplied by x minus x2. Now, remember, always your x1 as well as your x2 are your intercept points, right? Now, or to be specific, your x-intercept points. Now, we have substituted those x-intercepts. Now we have solved for our a, and we need to substitute our a here. Now, after you find your a, you need to substitute it back into this equation. So basically, this is minus 2. Now, what's next? You need to simplify this, right? And after you simplify this, you would arrive to your cubic equation. Basically, we would arrive to the equation of this cubic function. Now, let us go about doing that. Now, the first step, I'm going to try and simplify x minus 1 squared, right? So this is going to be equals to, so my y is going to be equals to minus 2. All right. Now, simplifying this x minus 1 squared is going to be x squared minus 2x plus 1. And remember, all this is multiplied to x minus 3. Now, when you arrive to this step, remember your BODMAS rule. You must first start by solving your brackets before you can multiply this -2. So basically, we need to multiply these two brackets, right? From there, after we've multiplied the two brackets, we can then distribute the -2, right? Now, let us go about doing that. Now, when we multiply the two brackets together, we would get x cubed minus 5x squared plus 7x minus 3. From here, we can then distribute the -2, right? So this is going to be minus 2x cubed. So it's going to be minus 2x cubed plus 10x squared. And this is going to be minus 14x plus 6. So basically here we have proved that our value of d, it is equals to positive 6, right? Because remember, this is our d, it's positive 6. Our value of c, it's minus 14, all right? Our value of b, it's positive 10, as you can see here. And also our value of a, it's minus 2, all right? Now, this is all for 9.1. Let us move on to 9.2, right? We have the equation, right? This is our original equation, and we would need to make use of it going forward to answer the preceding question. Now, they say determine the x-coordinate of the point of inflection for your f of x function. Now, what is your point of inflection? So your point of inflection is that point which separates your graph into two. So basically, one part of your graph would be concaved up, the other part of your graph would be concaved down. All right. Now, always to calculate our point of inflection, right, we need to find our second derivative and equate it to 0. Now, after we find our second derivative and equated it to 0, we would find the x-coordinate of our point of inflection. Now, let us say, for just interest sake, they ask us to calculate the coordinates, both the x and y coordinate for our point of inflection. Now, we know that this is the formula. Now, we know that this is the formula to calculate your x coordinate of your point of inflection. Now, what about your corresponding y coordinate? You would have taken the x coordinate that you would have found here and then substituted it into your original equation. From there, you would get the corresponding y value, right? But in this case, let us try and determine the second derivative. Now, first, we would need to find the first derivative. Now, if we derive this, right? So, the first derivative, and after finding the first derivative, we need to derive it to find the second derivative. Now, our first derivative is, remember, we take this 3 and multiply it with this minus 2, and then we subtract 1 from our exponent. Now, 3 multiplied by -2, right, it's going to be minus 6 x squared. 2 multiplied by 10, right, it's going to be 20, so this is plus 20x. And minus 14x is going to be minus 14. And remember, with regards to your positive 6, it's going to be 0, right? Now, this is our first derivative. Now, we need to derive this first derivative to find the second derivative. Right? So, to find the second derivative, we need to derive this. And after finding the second derivative, we need to equate it to 0, right? So, 2 multiplied by minus 6 is going to be minus 12x. That's deriving that. It's going to be minus 12x. And this is going to be plus 20. And the derivative of minus 14 is going to be 0. And remember, we need to take this second derivative and equate it to 0. So basically, minus 12x plus 20, we need to equate it to 0. Now, after, we need to solve for x, right? So first, I'm going to take this 12 to the other side, right? So it's going to be positive 12x. This is equals to 20. Then I'm going to divide both sides by 12 so that these two can cancel out one another. And our value of x is going to be 20 over 12. Now, simplifying further, your x coordinate of your point of inflection is equals to 5 over 3. So basically, here's 5 over 3. Now, for which values, 9.3 says for which values of x, it's f of x increasing, all right? Now, always whenever we determining values of x whereby our graph is increasing, we need to make reference to our stationary points. We need to determine our lowest turning point as well as our highest turning point, then make our answer in terms of those points, right? Now, let me show you how we're going to go about doing that. Now, first, we need to determine the value of r before we can get to answer this question. Because why? I say every time whenever you have a question whereby it asks you about values of x whereby your graph is increasing or decreasing, you need to make use of your turning points or your stationary points as your reference, right? Now, let us go about doing that, finding the value or the coordinates of r. Now, remember, to find our stationary point, we need to find the first derivative, right? And equate that first derivative to 0. All right. Now, the first derivative of this cubic function would be a quadratic function. And when we equate it to 0, we would factorize and solve for our values of x. Then we would get the 2x values at point Q as well as at point R. Now, let us go about doing that. Now, first, the first derivative, remember, we did it before, but then let us do it again for the purpose of this question, because even though you did it at 9.2, in order to get full marks on 9.3.1, you would have to do it again. Now, this is going to be equals to minus 6x squared, Right, so this is going to be minus 6x squared plus 20x minus 40. As I've said, you take this first derivative and equate it to 0. Now, whichever method you're comfortable with in terms of factorizing, just do it. If you want to do it, if you want to factorize this quadratic equation using the brackets method, you can do it. If you want to factorize it using the quadratic formula, just use it, right? Now, in this case, I will just factorize this using the quadratic formula, right? Remember, you need to write that down, write the formula down, and then your substitution as well as your values of x. Now, if you do that, your values of x, you should get x is equals to 1, or x is equals to 7 over 3. Now, these are the x values of my turning points. Now, I know that here it's already 1, so the 7 over 3 is going to be here at r, right? So the x value here is going to be 7 divided by 3. Now, I can answer this question of increasing and decreasing. Now, let me just take a highlighter just to answer this. Now, I'm going to highlight where my graph is increasing. Now, can you see that from here, going up to this point Q, your graph is decreasing? So basically, from here, so from your point Q up until point R, this is the only part whereby your graph is increasing, all right? And now you need to represent that using inequalities, right? So basically you need to show that, okay, between my point Q and R, this is the only part whereby my f of x function is increasing, right? Now, how would you go about doing that? Now, first you're gonna write your x in the middle. Now remember, your lowest value should be on the left and your highest value should be on the right, right? Now here, what is my lowest value? It is 1, right? And 7 over 3 is greater than my 1. Now, using inequalities, can you see that my x is greater than 1? So basically, any x value which is greater than 1 is increasing, right? I'm going to put this to show that, okay, my x is greater than 1. But this x, it should be less than this 7 over 3, right? Now, this should be your final answer. Now, let us move on to 9.3.2. Now, 9.2.3 says, okay, k, okay, for which values of k will f of x equals to k have exactly 3 different real roots. Now, what do they mean by that is that if you have a line, right, let's say that line is y is equals to k, that line must pass through 3 points on your graph, right? And in this graph, what points are we given? We're given point P, right, Q, R, and S. Now, making reference to this graph, that line of y minus k must pass through point P, right? And as you can see, point Q is under it, and also pass through at point R. So basically, this line y is equals to k has 3 points under it, right? So it has point P, Q, as well as R. Now we're looking for values of k for which this f of x function will have exactly 3 different roots. Now, how would you go about doing that? First, you need to find the corresponding y value for this value of r, right? Let's find the y value here. And how would you go about doing that? Let's just substitute 7 over 3 where we see our x here, because remember, this is our original formula, right? So you're going to say minus 2 multiplied by 7 over 3 cubed plus 10 multiplied by 7 over 3 squared minus 14 multiplied by 7 over 3 plus 6, right? And punching that into your calculator, you get a value of y as 64 over 27. Now, I need to represent this point up until this point, because remember here we have 3 points, right? I need to represent this in notation form. So I will just put my k here, right? And this k, it must be less than, right? Because it's less than, it's there, 64 over 27. And it must be greater than 0 at the same time. It must be greater than 0.